So let's talk about how AI models really learn. We kind of have this image of it being this totally automatic thing, right? But behind the scenes, there's actually a very human-driven control panel. Okay, let's dive in and demystify these dials and levers that make it all work.
Right? We hear this all the time. AI learns from data all by itself. But is that the whole story? That's the big question we're tackling today because the answer shows you the hidden art and, frankly, the science behind training these incredible models.
And the secret sauce here is a little something called hyperparameters. Now, it is so important that you don't confuse these with parameters, the weights and biases that a model learns on its own. Nope. Hyperparameters are the settings a data scientist tunes before the training even starts. Think of them as the master controls for the entire learning process.
To really get a grip on this, let's imagine we're sitting in front of this big ML control panel. And we're going to explore the three most fundamental dials that you're going to find on pretty much any machine learning project.
Our first dial is the learning rate. I always think of this one as the speed control. It basically dictates just how fast our model should try to learn from all the mistakes it makes.
What this really is just a number. But it's a super important number that's all about the size of the steps the model takes as it learns. See, every time it spots an error, it calculates a way to improve. And the learning rate tells it how big of a step to take in that direction. Is it a tiny little nudge or a giant leap?
And this brings us to what I love to call the Goldilocks problem, because it's just perfect. You have to get this setting just right. Set it too low, and the model takes forever to learn anything. But set it too high? Whoa, it just goes wild, bouncing all over the place without ever actually landing on the right answer.
So if your learning rate is way too low, the model is getting better, but the improvements are so tiny. We're talking microscopic steps here. You could literally be waiting forever for it to finally get somewhere useful.
Now, on the flip side, if you crank that dial way up, it's absolute chaos. The model takes these huge, crazy steps and just completely overshoots the solution. Its error rate bounces up and down erratically, and in some cases, it can actually get progressively worse. It's basically unlearning.
And this really just sums it all up. There is no magic number. You can't just Google the best learning rate and call it a day. Finding that sweet spot is an active experimentation. It totally depends on the problem, the model you're using, and the data you're feeding it.
All right, let's move on to the next dial on our control panel. This is the batch size, which I call the focus control. This setting determines how much information the model looks at before it decides to make an adjustment.
I mean, imagine you have a data set with 1 million photos. You wouldn't show the model all 1 million photos and then make one tiny little update. That would be incredibly inefficient. So instead, we break the data into smaller chunks, or batches. The batch size is just how many examples are in each of those chunks. Now, there are kind of two main schools of thought here. On one extreme, you have stochastic gradient descent, or SGD, which uses a batch size of just 1. It looks at a single example, makes an update. Looks at the next one, makes another update. It's fast, for sure, but the learning path is really noisy and jittery. The much more common approach is mini-batch, which finds a nice middle ground. It uses a small group of examples to get a more stable, averaged-out signal before it updates. It's all about balancing that speed with stability.
And this table, wow, this really drives the point home. Just look at these numbers. For a data set of 1,000 examples that the model will see 20 times, with a full batch, the model only updates 20 times, total. With a mini batch of 100, that jumps to 200 updates. But with SGD, a batch size of 1, the model adjusts itself a staggering 20,000 times. The choice you make here completely changes the entire dynamic of the training.
And that brings us to our final dial for today, the number of epochs. This is the repetition control. It's really all about one simple thing. How many times does the model get to practice with the entire data set?
Think of it like studying for a test. You wouldn't just read the textbook once and expect to get a perfect score, right? You'd review the material over and over. Well, that's exactly what an epoch is for a model. One full review of all the training data. And just like with us, real mastery requires repetition. It requires many epochs.
Okay, so let's connect the dots. If you have a data set of 1,000 examples and your batch size is 100, well, you just do the simple math. It takes exactly 10 of those batches or 10 iterations to see all the data one time. And that full pass, that's what we call one epoch.
So now we have our 3 dials, but the real magic, and honestly, the real challenge, comes from tuning them all together.
Finding that perfect combination is less of a rigid science and, well, it's more of a skilled art.
So let's just do a quick recap of our control panel. We've got the learning rate, our speed dial, we have the batch size, our focus dial, and we have the number of epochs, our repetition dial. Mastering these three is really the foundation of training any machine learning model effectively.
And this is probably the biggest takeaway of all. There are no universal best settings. The optimal setup is always this delicate balance between the unique quirks of your data and the practical limitations of your computing power. It's a constant process of experimentation and fine-tuning.
And that leaves us with one last thought. If so much of building powerful AI depends on a human's intuition and skill in tuning these dials, what does that really say about the so-called automatic nature of artificial intelligence? It seems the human operator is still very much at the controls.